This is Geometry, Unit 8, Day 11. We're working on page 676. Number 10, the name of two pairs of congruent angles. Well, if you look in here closely, we have an arc here, and we have two angles that are opening up to that same arc. So angle CBD is going to be congruent to angle CAD. Because remember, the angle is always half the arc. Then looking from a different perspective, looking at this arc, we have these two angles that are opening up and touching arc AB. So angle ADB is going to be congruent to angle ACB. We're going to do the same thing here. We see this arc. The angle that opens up to touch it is going to be angle MJL is congruent to angle MKL. Then, looking here at this arc, the two angles that open up to touch it, angle JMK is going to be congruent to JLK. Now, in some situations, they'll name these angles with a single letter, because there's really only one angle that's happening at each vertex. So here, look at this arc. This arc is made by angle W. So angle W is congruent to angle Z, because both of those angles open up to touch arc XY. And then we have this larger arc. So angle X is opening up to touch the endpoints called WZ. So angle X is going to be congruent, and notice that Y does the same thing. So they have to be congruent to each other. For numbers 13 through 15, we'll find the value of the variables. So, if we look here, like we've talked about before, if this is a quadrilateral inscribed in a circle, then opposite angles are supplementary. X plus 80 has to add up to 180. So subtract the 80, and X has to be 100. Similarly to that, we know that Y plus 95 has to add up to 180 because they are opposite angles. This quadrilateral is inscribed in a circle. We're here with number 14, opposite angles. 60 plus 2k has to add up to equal 180. We'll subtract the 60. Equals 120. Divide by 2. K has to be 60 degrees. Well, the other thing that we notice is that M and 60 have to add up to equal 180, and of course that makes M have to be 120. Number 15 is a little trickier. Notice you have to take some problem-solving thoughts on breaking this down. I know that 4B is half of both of those arcs put together. but I don't know that arc. But I know 3 of the 4 arcs, so 360 minus 240, 294. So that's going to give us a total of 66 degrees. Is going to have to be this one. So now we know that 4B is half of that arc. And that arc is 66 and 1/10. So 4B is going to be half of 176. Well, I can take half of 176. 2 goes into 17 8 times. Goes in there 88. Divided by 4. B equals 22. So let's look at what A would be. A, actually 3A, is going to equal half of its intercepted arc. 54 plus 66. Because the arc opens up and the inscribed angle is 3A. So 3A equals half of 110, 120. So half of 120 is 60. So divided that by 3, A has to equal 30. With number 16, the given information says that we have a 60 degrees central angle. If that's 60 degrees, then we know, if it's a central angle, we know the arc is also 60 degrees. Central angle equals the arc. The inscribed angle is going to equal half of that. So the measurement of angle B is going to equal half of the measure of arc AC. So the measure of angle B is going to equal 30. Here we have a star inside of a circle, not quite drawn perfectly. Each angle is supposed to be the same measurement, which is going to make each of the arcs the same. So we know we're going to take 360 and divide that by 5 equal arcs, which is 72. So we know each of these arcs is 72. And then each of the inscribed angles, notice, opens up to intercept that arc. So we're going to take the 72 and divide it by 2 to give us 36. So each of these are all 36. And then there are 5 of them, so the sum of all of those is 180. We're going to find the measure of each inscribed, was 36, and the sum of all of them, which was 180. So for question B, we have a star with 7 different points. So we have 7 supposed to be congruent arcs. So we're going to take 360 and divide that by 7, and that's going to give us 51.43. There's actually a continuous decimal, but we'll stop there with it. So we know that each of the inscribed angles are going to be that number divided by 2, which is approximately 25.71. And then the sum of all of them, because there are 7, we times that by 7. And if you use the exact value, not this rounded value, but you use the exact value, you would come up with exactly 180. And the reason why it's exactly 180 is because the inscribed angles are intercepting each of the arcs. The arc is 360 all the way around. Each is an inscribed angle, so that's half of the 360, which is coming out to 180, just as it did for question B. For letter C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 arcs that are supposed to be all the same size. So we know it's 360 all the way around the circle. We have our 9 arcs, so that comes out to be 40 degrees for each arc. 40 degrees for each arc. The inscribed angle is going to be half of that. And that value times all of the angles is going to come out to be exactly 180. Again, that's because each inscribed angle touches an arc. All of those are going to account for an arcs of 360. Well, the inscribed angle is always half of the intercepted arc. So if 360 are all the arcs, 180 are all the angles. For number 18, we're working with an inscribed angle and this intercepted arc. We have our inscribed angle, and we know that the angle is going to equal half of its arc. So notice how the angle opens up. This is an inscribed angle. It equals half the arc. So 8x plus 10 is going to equal half of the arc, which is 12x plus 40. Now both of these are even numbers, so you could distribute the half through, which is 6x plus 20. Then we collect our like terms. So we have 2x and 10, so x is going to be 5.